So welcome you all to this video lecture. So here in this video lecture we are going to discuss regarding to the tough topic interrupts. So in this interrupt we are going to have a detailed discussion regarding to the terms such as the need for interrupts. So IRQ interrupt request, interrupt hardware, how would this interrupts had been handling with regards to of multiple devices, so ISR, so acknowledgement, interrupt acknowledgement, and the latency. So with all to these terms, we are going to have a detailed discussion regarding to this in this video lecture. So the how the flow will be going here is from the machine instruction. This instruction going to get how it going to get decoded. So that decoded instruction is going for a microprogram. So there it will have senses those microprogram to a control store, micro instruction, micro routine, and microprogram counter. So there it will process some control signals. So final to that of a processor hardware, and after to this it will complete that instruction and will proceed for that. So in this regard we are going to have this discussion in this interrupt topic. So first thing is, why is this interrupt? So before to that, in previous video terms, we have detailedly see regarding to that of how the processor get communicated with an IO devices. So here we are going to see that that processor can access the devices. How it going to access the devices means through its registers, and it will check whether the device is ready for the data to transfer or not. So here there will be a problem with the continuous checking the devices. So which means due to that lacking of continuous checking of the device, the processor need to spend its time repeatedly, where means asking the devices whether it is ready or not. So this process is going to tell as a polling mechanism. So this is a mechanism that is called as a polling. So the polling is the term. So polling, this is the point which we need to have touch over here. So if the devices takes long time to become ready means, so the processor will be unnecessarily occupied over here. So which means that it will have that lack of stagnant there. So we need to have another mechanism through which the device itself need to perform the processor when its service is required. So this is where the interrupt is came into the picture. And with regards to this picture of this interrupt, we are going to see the further topics. So let us for an example, suppose here the interrupt suppose you have a processor executing a program, and an IO devices is also working over to there. So that the processor does not need exactly when the devices will become ready or not. If the processor continuously checks the device status, it cannot efficiently perform the other work. Like, so instead that the IO devices can send a signal to the processor. So here the IO device sends what a signal to the processor when it requires an attention. So that's sending a signal is called as an interrupt. So how it will send the interrupt? So with respect to the top IRQ. So this interrupt request IRQ is the term which means that this is the signal generated by whom, the IO devices, to request the processor to service regarding to the top request is called as the interrupt request. So the thing which we need to have here over this IRQ is the request from where the device to the processor. So the next is some handling methods such as interrupt hardware, enable and disabling interrupts, vector interrupt, interrupt nesting, arrangements of a priority group, controlling of the device interrupt and exceptions. So with all to do the things as we are going to have the further things as. So let us for an example, uh, what will happen when interrupt occur means, let us have a scenario inside a processor when an interrupt request arrive means, suppose here the processor is currently executing a program. Suddenly an IO device generates as an interrupt request means the processor does not normally stop in the middle of the instruction. It first complete the current instruction. After completing it only, the processor recognizes the interrupt and starts as the interrupt came right now and finish that process, which means that the current program is running over there. So after that, the current instruction need to get complete. So current program, current instruction. So the next is completing that instruction. So current program, current instruction, and complete the instruction. Complete instruction. After that, the interrupt, which is need to get recognized. So next is the interrupt service. So this is the flow when the interrupt occurs in the processor. So this is important. Why? Because that the processor should maintain a consistent state. So that only it will generate a complete instruction that is already in the process before transferring the control to the interrupt service routine. So the next is the ISR. So with respect to this of ISR, so interrupt service routine. So after recognizing this interrupt, the processor need to transfer the control to a special program. So which means that the processor is having that interrupt signal. So that interrupt service routine ISR contains some instructions required to service for the interrupting devices. So let us for an example, if a communication interface receives a new data means this interrupt service routine may read the data from the device interface and store it in a memory or a suitable processor register. So after completing that required services, then the processor return to that of program that was interrupted. So how will here the things will appear means the main program, main PGM, main program. So interrupt, so ISR. So after that completion, it will return to the top main program. So this is the flow we'll be having over in the interrupt service routine. So this interrupt service routine is not the entire application program. So it is just a how to say, it is a cameo based action based things. So it is a small routine especially designed to handle some interrupt, handle that specially designed interrupt. So the next is the interrupt acknowledgement. So this interrupt acknowledgement so how here it places means simply we can say the device is having, so after the device we are going to give some acknowledgement. This devices will give an acknowledgement that I have received an interrupt. So then it will send to the top CPU. So after that CPU it will give to the device where the interrupt controller will be there. So before to the top CPU to device, the thing which we're going to have is the interrupt acknowledgement. So how means here the processor may also acknowledges that it has been recognized that interrupt request. So this can be done using what means this interrupt acknowledgement control signal. So or through the interrupt instruction executed as a part of the interrupt handling. So depending on the type of architecture built over there. So here the purpose of this acknowledgement is need to get communicated to the top what the interrupting devices or the interrupt controller that the processor has accepted the request. So after to that the returning this interrupt ISR means, so there will be here the complete sequences will go from where to where means that IO devices to that of main program. So here first this thing is the IO devices. So after that it will senses some the interrupt request. So after the CPU completes the current instruction, so then it saves that the processor state. After that it will execute the ISR. So followingly services that the interrupt service routine services the devices. So after that it will return from the interrupt, restores the state, and it will continue the main program. So the next is the interrupt latency. So here if any interrupt request arrives at a time, let us for an example arrives at a time of 10 microseconds and the ISR starts us at the 14 microseconds. So here the 4 seconds is the what means interrupt latency. How means, if suppose an example the IRQ arrives at 10 microsecond. So whereas how at what second the ISR start means interrupt service starts means at the 14th second. So that lagging 4 microseconds is called as a interrupt latency. So the thing is, the interrupt latency is nothing that the time between the arrival of what? The interrupt request and the beginning of execution of the corresponding interrupt service routine. So therefore, that processor may have to complete that current instruction and saves it the required information before it starts as the ISR interrupt service routine. So therefore, these operations contribute what means contributed to that interrupt latency. So saving some large number of processor registers can also what increases the interrupt handling delays. So interrupt versus polling, we can say initially I said regarding to that of polling mechanism. So the polling is nothing that the processor repeatedly checking the devices, whereas this interrupt is nothing that the device requests the processor attention. Here it will request for the processor attention, not checking repeatedly checking. So here the polling is nothing that the CPU time is consumed for more for checking the status, where here the CPU perform the another works. It is related to that of another work thing. So whereas in the polling, the processor decides when it to need to check. Here the device initiates the request. So from in this video we have the clear picture like what means a polling. So from the polling, the CPU continuously checking for the devices. So there we have created this interrupt. So this interrupt get interconnected with the IO device interrupt request IRQ and the CPU. So after those interconnected network from this IO device IRQ and CPU, it will complete for it will move for what means the complete current section, where that it will saves us the current instructions, which means that completes us the current instruction. After that the interrupt service routine will proceeds. After that it will perform that service data. So through that after completing that it will return from that interrupt, continue with that main program. There will arises a latency term interrupt latency. After that multiple interrupt request will provide. So the next the priority things is it will come in the upcoming videos. So in the next video we have those things as how it will going to get handled and priority arbitrations will come there. Thank you.